Hello everyone, welcome to my YouTube channel. So today I am going to discuss an interesting problem from Tifr GS 2021 MCQ. Actually I missed this problem in the last video. Okay, so this is a very important and fine problem. So for a positive integer n denote the unique positive real root of this equation x power n plus x power n minus 1 plus dot 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 plus x minus 1 equal to 0. So observe that, so basically say fx equal to x power n plus x power n minus 1 up to x minus 1. So f of 0 is equal to minus 1 and f of 1 equal to n minus 1. Okay, so that means if n equal to 1, then we can see f of 1 equal to 0. So 1 is a real positive root of f, and for n greater than 1, f of 1 is positive and f of 0 is negative. So by intermediate value property, there exists an belongs to open 0 1 such that f of an equal to 0, right? So, and in question it is given that an denote the unique positive real root. So in particular we can take that so the an lies in between 0 and 1. So a of a1 equal to 1, and from n greater equal to 2, an belongs to the open interval 0 comma 1. Okay, now we need to show that this sequence is basically convergent, and to show that, first observe that for n equal to 2, the equation is basically x square plus x minus 1. If we solve it, then it becomes this, but we are taking positive root, right? So that means a2 equal to minus 1 plus root 5 by 2, which is less than minus 1 plus root 9 by 2, which is same as minus 1 plus 3 by 2 equal to 1. So we have a2 less than a1. Now inductively, let's assume an less than an minus 1. Okay, now we need to show a n plus 1 is less than an, right? So observe, so let if possible a n plus 1, here it is for some n, and I need to show that a n plus 1 less than a n for that n. Okay, so if possible a n plus 1 greater than a n, then a n plus 1 power n plus a n plus 1 power n minus 1 up to a n minus 1, this is greater than a n power n plus a n power n minus 1 plus a n minus 1. Now this is 0 because a n is the root of that equation x to the power n plus x to the power n minus 1 plus dot 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 x and x minus 1, right? So that means this is 0. So we have a n plus 1 power n plus a n minus 1 is greater than 0. Now if I add a n plus 1 to the power n plus 1 both side, we get a n plus 1 to the power n plus 1, this a n minus 1, this is greater than a n plus 1 to the power n plus 1, which is strictly greater than 0. But according to given condition, a n plus 1 is the root of this equation, hence this is the contradiction. Hence this gives a contradiction. Because according to given case, this must be 0, because a n plus 1 is the root of the equation x to the power n plus 1 plus dot 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 plus x minus 1, right? But it is strictly greater than 0. Hence this gives a contradiction. This will imply a n plus 1 less than a n, and in this way this will imply a n is monotone decreasing. Again, a n belongs to open 0 1 for all n greater or equal to 2, right? So this will imply a n is bounded below by monotone convergence theorem. A n is convergent, right? By monotone convergence theorem, a n is convergent. Okay, let a n goes to L. Okay, now we have the equation x to the power n plus x to the power n minus 1 plus x minus 1 equal to 0. Add to both sides, we will have x to the power n minus n plus x to the power n plus 1 plus x plus 1 equal to 2. Okay, now if a n converges to L, then as n goes to infinity and x belongs to open interval 0 comma 1, right? So that means x belongs to open interval 0 comma 1. So for x belongs to open 0 1, summation x to the power n greater or equal to 0 is convergent, right? And it converges to, by geometric series, 1 by 1 minus x, right? So that means, and since a n tends to L as n goes to infinity, so by above condition, so from star we have summation n greater or equal to 0 L power n is 2, right? And since an converges to L, and L also belongs to, and since an converges to L, that means L also belongs to 0 1, because an is monotonically decreasing and converges to some value L. So this will imply 1 minus 1 by L equal to 2. So that means 1 minus L equal to half. This will imply L equal to half. Hence, by using the basic conception, we can clearly see that limit n goes to infinity a n, this limit is half. Hope it is clear to all of you. Thank you.